Okay, so here we start to compare triangles, and we start off with the idea of congruent triangles and understanding what that even means to say that triangles are congruent and how we can work with them. So let's dig a little into that. Now, we're not trying to figure out if they're congruent yet. Right now, we're told they're congruent, and we want to just make those comparisons appropriately. So remember the idea of congruence and our symbol there. It means identical. So it's the same shape, same size. Now think about it that way. Same shape. The angles control the shape. So not all triangles are the same. We can have a right triangle. We can have an obtuse triangle. They're not the same shape. The angle measurements compare the angle measurements affect the shape. And then the size. The size is controlled by the length of the segments or the sides. So we could have a small equilateral triangle, or we can have a really big equilateral triangle. The angles are the same, but the size is different. So again, we want to think of congruency as same shape and same size. And congruence is not affected by translation, rotation, or reflection. So translation is just a slide if we move it over. A rotation is if we spin it around. And a reflection is like a flip, like a mirror image of when we flip the image. They do not affect congruence. The two shapes before and after are still identical. So when we talk about congruent triangles, by definition, two triangles are congruent if and only if their corresponding parts are congruent. Now, remember, we've used this word corresponding before when we talked about corresponding angles. All that means really is that they line up with each other. If we'd laid one triangle right on top of the other, the parts that line up are the corresponding parts. Yeah, we might have to spin it around or flip it over, but once we get the triangles lined up, those are the corresponding parts. So what we're saying here is that two triangles are exactly identical, congruent, when their corresponding parts are all congruent. And we can also turn that around. If we know the corresponding parts are congruent, we can say that those triangles are congruent. And we can say that when the triangles are congruent, all of their parts will be congruent. So we have this acronym CPCTC. Now, it really does represent the same content. When two triangles are congruent, all of their corresponding parts are congruent. So CPCTC just rewords that. The corresponding parts of the congruent triangles are congruent. So with CPCTC, we know the triangles are congruent, and now we're talking about their parts. So the corresponding parts of congruent triangles, that means we have to have congruent triangles first. Their corresponding parts are congruent. CPCTC is an acronym that we want to get very comfortable with. The corresponding parts of congruent triangles are congruent. What does CPCTC really allow us to do? Well, it allows us to identify the corresponding parts and then conclude that they are congruent. So here, if we had triangle ABC is congruent to triangle QRS, what I like to do is kind of number these. So ABC, first letter, second letter, third letter. QRS, first letter, second letter, third letter. Well, then the first vertex A corresponds to the first vertex Q. The second vertex B corresponds to the second vertex R, and so on. And that little double arrow symbol just means corresponds to. Sorry, means corresponds to. Now, again, we're just breaking down what CPCTC really stands for and what it does for us. So again, if we take our triangle statement here. We have a congruent statement, triangle ABC. So again, I'm just going to number these. 1, 2, 3. So vertex 1, vertex 2, vertex 3. And we're saying it is identical or congruent to the other triangle, triangle QRS. And again, I'm going to just put 1, 2, 3. Well, then what we can say is that angle A corresponds to angle Q because that's vertex 1 with vertex 1 or angle 1 with angle 1. And since the corresponding parts of those congruent triangles are congruent, we can say that angle A is congruent to angle Q. And it works for the sides or the segments as well. Moving to the right side of the picture. Segment AB. Well, segment AB is 1, 2. Right? We're using the same numbering system. 1, 2. So the segment that goes from vertex 1 to vertex 2 is the same from the other triangle, vertex 1 to vertex 2. Those segments correspond with each other. They both go 1 to 2. So we know that AB is congruent to QR. This idea of corresponding parts, and we want to put those letters in the matching order or corresponding order. So look at the next one, BC. BC, if we look at our numbering, goes from 2 to 3. 2 to 3. Well, we have to match that from the other triangle. R is letter 2, S is letter 3. So segment BC corresponds to segment RS, which means segment BC is congruent to segment RS. This is called corresponding order. We put the letters in the same order. Segment AC, look at our first triangle. A is 1, C is 3. So it's the segment connecting vertex 1 to vertex 3. And we're going to match that in the other triangle. Q to S, vertex 1 to vertex 3. So AC corresponds to QS. The corresponding parts of those congruent triangles are congruent. So AC is congruent to QS. Again, all we're doing, even without the picture, the way that those triangles are named tells us first letter matches first letter, second letter matches second letter, third letter matches third letter. So angle B and angle R, they match. Angle C, angle S, they match. Segment BC, 2 to 3, matches segment RS, 2 to 3. So it's really important that we get that congruence statement correct. This triangle is congruent to that triangle. And we'll show how to do that now. In order for CPCTC to work, we have to know which parts match up. Remember, the corresponding parts of the congruent triangles. So we know the triangles are congruent. We have to know which are the corresponding parts. So look at our picture here. If we took triangle ABC and just slid it over, right? If we just took triangle ABC and slid it over, A would land right on Q. B would land on R. And C would land on S. So we can actually just see which are the corresponding parts. Sometimes when it's reflected or rotated, it's not as obvious. So we need some strategy. But here we just have a translation, a slide. when we write our congruent statement comparing the two triangles, we have to make sure that we put all those letters in the correct order. So remember how to name a triangle. There are 6 different ways to name a triangle. And the first one we can name however we want, but the second one has to match. So I'm going to use our numbers again. I'm going to say A is 1, B is 2, and C is the third corner. Those are our 3 vertices. And I'm going to match that in the second one. Since A lines up with Q, I'm going to call that corner 1. B lines up with R. I'm going to call that corner 2. And C will correspond with S. So I'm going to call that corner 3. Again, keeping it very simple with just a translation here. So now I can name the first triangle however I want, but I have to match it the corresponding order when I name the second triangle. So let's look at a couple examples here. If I name the first triangle ABC, that's corner 1, corner 2, corner 3. Well, then I'm going to match it with the second triangle. First corner, second corner, third corner. So QRS. But what if I name the first triangle BAC? So look at my triangle, BAC, that's 2, 1, 3. Well, I have to match that from the second triangle. Vertex 2 is at R. Whoops, sorry, my screen. Let me get back there. Apologies. Okay. I have to match it in the same order. 2, 1, 3. Well, vertex 2 was R. Vertex 1 was Q. And vertex 3 was S. And the same idea is happening in all of these. CAB. Well, if I look at my first triangle, CAB, that's 3, 1, 2. 3, 1, 2. I need to match that in the other triangle. Corner 3 or vertex 3 was S. Vertex 1 was at Q, and vertex 2 was at R. So the first triangle, however I want, but the second triangle has to be in corresponding order. And numbering the angles 1, 2, and 3 is a nice, easy way to do it. Let's look at a few more examples. So looking at our strategy, we're told these triangles are congruent, but we have to write out congruent statements. So we want to understand this. In my first triangle, just number them. Vertex 1, vertex 2, vertex 3. Now, it's certainly helpful to find the missing angle. So if we have 80 and 40, we can find out that our missing angle here is a 60. So I did this 1, 2, and 3. Now I'm going to match that in the other triangle. The 40-degree angle was number 1. So the 40-degree angle is number 1. The 60-degree angle is number 2. The 60-degree angle is number 2. The 80-degree angle is number 3. The 80-degree angle is number 3. And we can find it. We have to know that they match. We've done that in our previous lessons. So I marked them off. 1, 2, 3, 1, 2, 3. Now I can read them off in whatever order I have to. For example, segment CP. Well, that's the side connecting 1 to 2. C to P. I have to match that. So again, 1 to 2, I'm going to go to the other triangle, 1 to 2, and that's F to T. So FT. I cannot have those letters backwards anymore. The first one, however you want, the second one has to match. If I talk about segment LC, it's from 3 to 1. That order matters. I have to match it 3 to 1. So it has to be ZF. Now the same rules when we name the angles. We have to be careful when we name the angles as well. Let's look at naming an angle. PCL. PCL. That was 213. I have to match that from the other triangle. 213. So TFZ. I have to follow that same pattern, corresponding order. I have to know if I'm talking about a segment, 2 letters, an angle, 3 letters, or a triangle, 3 letters. So make sure that you're aware of what parts you're talking about and what symbols you're using. So let's try to fill in a few here. So they started it off, which means we have to match it in our second when we fill in the blank here. So let's see what they're doing for us. In number 1, WV. Well, first of all, look at the triangles. These are already labeled 1, 2, and 3. And what I'm doing is I'm talking about the arcs in the corners. Look at those little arcs. Next to V is 1 arc. So I'm going to call this angle 1. Next to W, there are 2 arcs. So I'm going to call it angle 2. And next to X, there are 3 arcs. I'm going to call that angle 3, or the third corner. So that's my 1, 2, and 3. Same thing in the other picture. 1 arc, 2 arcs, 3 arcs. So we want to make sure that we have this correct segment, but also the letters are in the correct order. So look at number 1, WV. Well, WV, and I'm putting an arrow because that's the order. They went 1, I'm sorry, erase that, fix this, sorry about that. WV, they went 2, 1. I have to match that. It's side 1, so I already know it's CD, but I have to put it in the correct order. WV went from 2 to 1. I'm going to do the same thing from 2 to 1. From 2 to 1. So I have to match it with segment DC. The order has to be correct. Let's look at another. I'm gonna do number 3 next. Let's just do both segments and then we'll do both angles. EC. So that's over here. E to C. That looks like 3 to 1. Well, I'm going to match that 3 to 1. 3 to angle 1. So it has to be XV. Corner 3 to corner 1. Angle 3 to angle 1. Notice it's the same side. The side mark 3. But we have to put the letters in the correct order. We could call these something like a directed segment because we care about the direction. We start at this corner and go to that corner. ECD. ECD. So we need to find that. E is 3 arcs, C is 1, and D is 2. Well, we're going to match it, 3, 1, 2. So we're comparing angles. 3 is an X, 1 is a V, and 2 is at W. And then finally, we can do our last one, VWX, VWX, and we're going to match that with VWX went 1, 2, 3, so we're going to do 1, 2, 3. C, D, E. And finally, for the whole triangle, we compared 2 sides, we compared 2 angles. Now we're going to compare the entire triangle and say the triangles are congruent. They started it with XVW. Look at our pattern, XVW, and we're going to mimic that. So triangle to triangle, XVW. That is going to match E. What comes next? Sorry. E. V matches up with C. And then finally D. Let's take a look at one more. Now these triangles, it's the same exact problem. The triangles just happen to be pushed together. They share a segment. They share a side. But everything's marked for us still. 1s, 2s, 3s, everything's marked. So let's do this. ST. S to T. That's 2 to 3. So we're going to match it on the other triangle. 2 to 3. R to I. So segment RI. We're doing the exact same thing. SI. We're going to match that with RT. SI goes 1, 3. We're going to match that with 1, 3. ISR, angle ISR, angle to angle. So fill that in right away. You can't compare apples to oranges. You can't compare segments to angles or angles to triangles. So angle ISR. Look at your pattern. 3, 1, 2. And we're going to match that with 3, 1, 2 from the other triangle. RST, angle RST is going to be congruent to angle SRI. And finally, triangle STR is congruent to triangle RIS. So corresponding parts of the congruent triangles are congruent, CPCTC, and everything has to be named in corresponding order. So we establish a method of doing that by following a pattern. Right? So working with congruent triangles. Next, we'll learn how to, for us to determine if the triangles are congruent, and then do this. So we're going to add a step before this. But for right now, we know the triangles are congruent, and we have to be able to identify their corresponding parts because we now know they're congruent. If angle RST measures 60, well, then angle RSI measures 60. If segment SI is 40 meters, well, then segment RT is 40 meters. Same shape, angles have to match, same size, corresponding sides have to match or be congruent. All right, we'll stop there and we will pick it up next time.